Okay, guys. So we're going to use the same steps that we used when we calculated Newton's second law, right? The first step in solving any of these word problems or any word problem at all is to read the problem and try to understand what is it asking? What is this problem asking me to answer? What is the question? Okay. And the surest way to find the question in a word problem is to find the question mark. Okay. Here's the question mark. So the question mark comes immediately after the question. And in problem number one, what is the question it's asking? Cody, you've got a lot to say today. Why don't you go ahead and tell me, what's the question it's asking me in problem number one?
What?
What is the question that it asks in problem number one?
How far did he drive?
How far did he drive? So how far did he drive? That is going to be, is that going to be a speed, a distance, or a time?
Distance.
That's going to be a distance. So that answers this question. What are we trying to find, right? So that's going to help us decide which equation to use. We have three equations that we use for solving these problems. Okay, they're in your notes. I'm going to rewrite them up here in this nice. Let's use pink. Okay, the first equation is d equals v times t. The next one is v equals d over t, and the third one is t equals d over v. Okay. This is distance, speed, time. Okay. So which equation should I use here, do you think, Elijah? Is Elijah on the call?
No.
Okay.
You have Devontae, Maya, Ryan, and Summer.
How about Maya? I bet Maya knows this. Which equation should I use to find the distance? Maya? Which equation would you use, Maya? Okay, we're going to proceed. The equation we should use to find this is going to be d equals v times t. It's going to be this equation right here. Oh, that's not what I'm trying to draw. This equation right here. So d equals v times t. That's step one. We write the correct equation. Okay. Step two, we're going to replace the letters in this equation with numbers from the problem. We're going to say d equals, and we're going to find the number that goes in for v, for the speed. What is the speed here, Devontae? What's the speed in problem one? Javante? $30 miles per hour. Yeah. So the speed is 30. Actually, miles per hour here. You can see 30 miles per hour. Yeah, it's 30. And then we're going to multiply that by t. What was the time here? Anybody? What was the time here? How much time did Ronnie travel?
2 hours.
Yeah, someone said 2 hours. 2 hours.
I did. It was me.
Yeah, so it is 30 times 2. D equals 30 times 2. Now, step 4 asks us to solve and check our work. Okay? That's what we're going to do. 30 times 2 equals 60. So D equals 60. Now, I want to point out, on the quiz, what you'll look for is this. You want to use the correct equation to solve. When you go to do your quiz, this is what you're going to have. Okay? It's going to give you different options. And like option B is going to say B. D equals 30 times 2. And that'll be the one you select. Okay? It might give you different options. It might say like you know, d equals 30 over 2. It might give you an option, like A might say d equals 30 times 2, right? Or it might say t equals 2 times 10 or something ridiculous. You're going to want to select the one that fits your problem, okay? And for now, for these first set of problems, that's going to be good enough, okay? The important thing we'll point out to you guys here is what we're trying to do is we're trying to work out how to solve word problems. That's what we're going to do in this little chunk of our physics class. Okay?
And that's one of the big differences between how I approach algebra and how he approaches his science class. He's looking for you to set up the equation. I'm looking for you to actually solve for 60.
Yeah. Yeah. And actually, we're going to see as we get further down here where we have to solve in order to actually get the answer right anyway. But on these earlier ones, we're just solving to check our work because that'll let us not choose the ridiculous answer. We'll see a good example here. Well, I can show you a good example of that here. Problem number 2 says, Lexi walked for 10 hours at a speed of 2 miles per hour. How far did she walk? Well, again, we're asking how far, and how far is going to be measured in distance, okay? So we're going to use our distance formula, d equals v times t, okay? We're going to rewrite that, d equals, and v is going to come from the speed here, 2 miles per hour, 2 times, and t is going to come from the amount of time, the time interval, times k. And then we're going to solve d equals 20. But say you need to figure out how far she walked, and then you're going to use that amount to answer another question. So say it took Ron 2 hours to go that same distance. Well, you're going to need this number to punch into the next problem you get. So we do need to solve. But on the quiz, we're going to be looking for this. Oh, this. Okay? I want to see that you guys know how to find the answer. I want to see that you guys know how to show your work. Okay? Now, digitally, when we're doing all this stuff over Google Forms and things like that, the best way for me to get you guys to show your work is to see that you guys can select the correct equation from the options. And I think that's pretty good. I think that does a pretty decent job. Not perfect. It took James an hour to drive 8 miles to the mall. What was his average speed? This one's a little different. It's asking for something else, isn't it?
8 miles per hour.
Okay. What was his average speed? So to start out with, we need to look at this, the question mark. What is this problem asking me for? And I'm going to ask somebody else to answer here. Let's see. Summer. Summer, can you tell me what is this problem asking for? What do we learn from that question mark? Okay. So I'm not getting any feedback from Summer. Let's see if Ryan, can you tell me, please, what's problem 3 asking me for? What's the question that's being asked in problem number 3? Oh, there's Summer in the chat. It's asking for speed, okay? Speed. And our equation for speed is up here. It is this one. It's v equals d over t. So that's where I'm going to work from, okay? V equals d over t. Now, for those of you who weren't here earlier when we talked about this and who didn't hear Mr. Wayne explain this, d over t means d divided by t, okay? Or how many times t will go into d, or d over t in a fraction. These all mean the same thing. So v equals d over t. Right? So the next thing we need to do, step 2, is we need to take and rewrite this, but we're going to replace the variables with the constants that I give you from the problem, from the word problem. So what is the distance here, Cody?
8 miles.
8 miles. Okay. And what's the time interval given here?
An hour.
1 hour. 8 miles and 1 hour. So we go ahead and divide that. That's going to give us the velocity, sorry, the speed equals 8. We use v for speed because later on we'll actually be talking about velocity instead of speed. And we're going to use the same math to answer that.
And I'll this is on my spot.
Velocity is a lot like speed, but it's different. It's speed with the direction. We're not really ready to get into that yet. I don't want to confuse you guys. But v means speed for right now. Later on, we'll stop talking about speed and only talk about velocity. Okay? So yeah, so we've got, I got you raised.
Sorry.
V equals,
Okay.
yeah. Anyway, that's what we got.
It actually clears your stuff too.
Yeah, it's okay.
Normally it clears mine.
All right, so problem 4 says Bella walked 3 hours and made it 3 miles to Zanesville. What was her average speed? Okay. What was her average speed? So we're gonna choose a pin here. It's asking for her speed again, right? If it's asking for speed, we're again gonna use the V equation. I call this the V equation because it starts with a V. V equals D over T. V equals, and then we're gonna punch in the amounts from the problem. Okay, 3 miles, 3 hours, 3 over 3. Her speed then was 1 mile per hour. 1. Down here, problem 5. Jim rode a dirt bike for 5 hours and went 25 miles. What was his average speed? If it's asking for average speed, again, we're going to use that as our cue. V equals D over T. And then we're going to rewrite it. V equals, the D comes from the amount of distance that's described. So we're going to take this, and we'll put it in here, 25, divided by the T, the amount of time that takes place, 5 hours. V equals 25 over 5. When we punch that in the calculator, we can solve that out and find that V equals 5 miles per hour. Now, this is important because that tells us something about Jim's dirt bike, like how fast he rides it. We can use this 5 miles per hour. We can punch it into other problems. Okay? If Jim can ride 5 miles per hour and he rides in a straight line from 3 o'clock to 6 o'clock, well, that's 5 miles per hour times 3 hours. We can go out, we can show a new distance based on that average speed. Okay? We're going to start messing with that here in a couple problems, but I just wanted to give you guys a quick preview of that. We'll scroll down here. It says a train went 15 miles per hour and it went 30 miles. How much time did it take? What's it asking me for here? Someone other than Cody? Ryan, what's it asking me for here? Huh. How much time? Okay. So T equals D over V. That's the equation directly from our notes. That's one that you should get used to writing again and again and again. T equals D over V. Or rewrite it again. T equals, the distance from the problem comes from right here. Okay? 30 over. And the velocity, sorry, the speed comes from here, 15 miles per hour, 15. We rewrite that, t equals 2. After you punch in the calculator, that's what you're going to get. So that's all fine and good, but up until this point in physical science class, I haven't asked you guys to focus on this solve, right? This is not what I've been asking you guys for. So far, as I said earlier, I've been satisfied with this math problem as your answer. And sometimes I'll still accept that as your answer. But starting with question 7, we need to do something with the solve, and so we're going to have to do it. It's going to be part of what I'm asking you to do. And we'll see that here. It says Clint walked down the hallway at 2 feet per second, went 120 feet. How long did it take him? If he started at 1 o'clock, what time was it when he finished? Okay, so what's it asking for in this problem? Well, there's a question mark here. There's a question mark here. I suspect that I need to answer one of these questions in order to answer the other question. All right? And because I'm a pretty nice guy, despite what people say, I think that for now, I'm going to put the first question you need to answer first in the problem. Okay? So for now, we need to find out how long did it take it. That's where we're going to begin. Okay? Well, if I started at 1 o'clock, and I didn't actually, no, I didn't do that. No, we need to answer this question first. What time was it? No, I was right. Yeah. We need to find out how long did it take it first. Okay? So we're going to solve that first. If I want to know how long did it take him, that's a t equation. T equals. That's our time interval. The amount of time it took Clint to walk down the hallway. Okay? Time equals d over v. Okay? Time equals, well, the distance was 120 feet. The speed that he went was 2 feet per second. Boom, there we go. We know how many seconds he went. He went for 60 seconds. That answers question number 1. All right? But to answer question number 2, what time was it when he finished? We need to take, yes, Cody, you're way ahead of us, man. We know. I'm trying to explain this for everyone who's not way ahead of us. But yeah, you're right. It was. So we had that 60 seconds. If it started at 1 o'clock, plus, 1 minute, right? That's going to give us 1:01. He finished at 1:01. He ended his walk at 1:01. This is a very, very, very oversimplified example of how we need to find this amount to find this final answer. Okay? I was trying to give you guys a very, very obvious example of that before we get into it really heavy, because that's where the physical science class is headed. We're going to be talking about multiple part questions. When Mr. Wayne was in college to become a math teacher, some of his exams, especially towards the end of his studies, some of his exams might consist of just 1 or 2 actual word problems, but there might be 4 or 5 or 6 steps to solve that along the way.
And if you think that sounds like it would take a while, it did. There were a couple of times that I had over 3-hour-long exams. There were like a couple of questions, and it was an entire packet that he gave me to answer it.
Yeah, so, but that's what the real world looks like, okay? Sometimes you're trying to figure out, like, exactly how much can this bridge hold, right? Or maybe you're asking, like, how strong do I need to make this bridge if this bridge can hold this much weight for this much time in these sort of conditions? Sometimes you have lots and lots of different things that factor into a real world problem, and you need to start at the beginning, figure out what you know, and how you can use that to solve the answer you end up with, this 101 PM answer, okay? So if I want to know, okay, Columbus is 50 miles away and I can travel 30 miles per hour, it's 3 o'clock now, I need to get there by 5:01, what time do I need to leave by? That's a whole lot of math to throw in, right? But we just take it a step at a time. We take what we know, we answer the questions that we can up front and see how we can use those answers to answer later questions. And that's what physics does for us. That's what algebra does for us. Got through algebra and problems. So, here's another one.
Thank you for being so gracious.
Yeah. I walked home from school. I left at 3. I got home at 4. My house is 5 miles away. What was the time interval and what was my average speed? Obviously, at the end, I'm trying to find the speed, right? I want to know the velocity, v equals. But I'm probably not going to start there. I probably need to figure something else out first. Okay? The problem, v equals, right? It says, what was my average speed? Well, that's, d over t. We know that. The problem is, I should say, the challenge is that I didn't tell you what t is. We have to find t first. Okay? If I left at 3 and I got there at 4, what was my time interval? 4 minus 3. It was an hour. Okay? Now that we solved this part of the problem, this 3 to 4 part, sorry, my smart board's not being very smart. Now I can go in and I can actually solve the physics problem using the equations that I gave you. Okay, so v equals d over t. V equals the distance being 5 miles divided by, what took me an hour, 1 hour. So my speed was 5 miles per hour. These are very, very early examples of why you would need to have to be able to solve the first problem to solve the second problem. Okay. I might give you guys a quiz where the answer to the first problem will let you solve the second problem, and that will let you solve the third one, let you solve the fourth one, the fifth one, just for funsies. Because it sounds like a great time. I'll bet you guys will love it. You think? Probably not. Maybe not. But that's what the real world looks like. Okay. Ellie rode her bike from noon to 3 at a speed of 2 miles per hour. What was the time interval? How many miles did she ride? Okay. So I know that it's asking me how many miles. How many miles? Right? But I also gave you the hint. Okay. What was the time interval? This hint right here, by the way, it might not stick around. I might skip this. I might assume that you guys know that you need to find that first. That's not for a while. That won't be this unit. But it's coming. Okay. Ellie rode her bike from noon to 3 at the speed of 2 miles per hour. How many miles did she ride? So at the end, I'm looking for distance. D equals. D equals V times T. D equals VT. I'll rewrite it. D equals, well, she rode at a speed of 2 miles per hour, 2 times. What's the time? Well, I didn't tell you the time. So this is where we got to break out our pencil over here in the corner of our paper, and we got to say, well, from noon to 3 is 3 minus 0, because noon is 0. 3 minus 0 is 3, right? That comes right over here. So how far did Ellie ride? Ellie rode 6 miles. D equals 6 miles. We'll get the units back in there later. Remember, I like to start out without units and then work our units back in. Okay? Now, you'll notice that along the way here, I haven't made like big clear lists of where all my amounts came from and all that. Mr. Wayne asked me about this earlier, and it brought up a good point. Like, why don't I have you guys start out with like, okay, D equals B equals T equals, and then punch it into the equation? This is because in the past I've asked people to do that, and then they get stuck because they think, oh, I'm solving for V or I'm solving for T, right? It's not a bad idea to ask you guys to keep track of this stuff, but I think that sometimes, for me anyway, the way I like to do math, the easiest way to keep track of it is to leave it where it is. 2 miles per hour, that's going to be my speed, okay? Noon to 3, that's going to be where I get my time interval, right? So D equals V times T, and then D equals 2, because it comes right from here, times T, we had to figure out, it's, 3 minus noon, 3 minus 0 is 3, so that comes down here. Okay. There's a couple different ways you can organize your information to do your word problems. There's probably a better way to make it real clear on your paper. Yeah.
That's how I normally have them write out equations and solve in
Oh.
class, keeping it,
Height-wise, yeah, so you
yeah,
just, instead
keeping
of,
it vertical so they work their way down.
right, so instead of just going across, he has you guys do this as a line, and then everything in here is a line on your paper, and then everything here is a new line on your paper. This is line 1, 2, 3. Not a bad idea. That's the way I like to do it too. Sometimes I get a little stingy with how much paper I take up. But yeah, his way is the easier way. It gives you more room on your paper to organize your thoughts. But we're doing the same thing. We're doing the same thing. All right, down here, I didn't even work hard enough to give you guys word problems. I thought, well, I'll give them a few where they just take the amounts I give them and do the equation. This one, this first one, it's asking for D. D equals V times T. D equals 3 times 3. D equals 9. Yeah. This one, V, V equals D over T. V equals 16 over 4. V equals 4. Okay. And problem number 12, we're doing the same thing already over here. And yet another color. Let's try pink. T equals 20 over 10. No. T equals V over V. T equals 20 over 10. T equals 2. Okay. So this is how we're going to solve these. We're going to go a step at a time. I want to go back up and I want to just point out again these steps that we use to solve these problems. All right. Step 1 is always going to be decide which equation to use. Okay. In other words, find the question mark and answer that question. If you can't answer that question, find another question mark and answer that one first, and then go back. Okay. Step 1, decide what equation to use. What are you trying to find? Next, replace the letters in the equation with the numbers from the problem. Be careful to put them in the right place. If you put them in the wrong place, then your equation is going to be messed up, and you're probably not going to end up with the right answer. All right, rewrite the math problem that needs to be solved, and then check it. Solve it to check it. Once you do step 4, sometimes you need to use this to go back to step 1 for a different question. Okay? You got to be ready for that because that's what's coming. Once you get to step 4, you might be starting over on a new question within the same math problem, within the same physical science problem, I should say. All right? I think if you guys follow these steps that you will be well on your way to answering any of the word problems as long as you have the equations. As long as someone teaches you the equations you need to solve these problems, you should be in good shape. If you don't have these written on your paper already, you should write them right now. Okay? D equals V times T. V equals V over T. Speed equals distance divided by time. and time equals the distance divided by the speed. Okay. Fairly easy if we have these equations handy. You should always have these equations handy. All right. I teach science and I have to have these equations handy because I get thinking, I'm thinking about 10 other things at the same time. I need to know where they're at. I need to have something to refer to, some reference point. I used to keep these up on my wall above my whiteboard, and I kind of had a sort of a system where I would say, if it asks how far, it's answering this question. If it's asking how fast, it's answering this question. And if it's asking how long, weirdly, we say how long, we're talking about an amount of time. It's asking that question. That's not a bad way to put that in your notes. It's not a bad little note to put on your notes. How long means time. Okay? But if you have these equations and you follow these steps here, you should be in good shape for solving any of the word problems that we throw at you in physical science or in algebra. All right? I'm going to turn things over to Mr. Wayne here in just a minute, but I am going to leave the chat up in case there are any questions about this homework. I would like to point out again, and I'll go ahead and write it in the chat. We do have Unit 4, Section 1 practice, Part 2. We do have that tonight. That's going to be your homework tonight, as well as some other assignments in the other classes. All right. So thanks for playing. We'll see you here next time on The Price is Right.